Now, let's do a little example. And this is which of these have y as a function of x? Okay, this is an x here. So we've got a is going to be y equals x squared. B is going to be x equals y squared. We're going to have C is x squared plus y squared equals 25. D is going to be, we have 8y cubed equals x squared. And finally, we've got E is y equals x cubed minus x. All right, so we want to attack each of these with the vertical line test. Now, I'll just warn you in advance, you might not know how to graph some of these, and that's okay. We're going to go over how to graph a lot of these. Part D, I'm just going to kind of show you what it looks like, but for the other ones, we'll eventually see how to graph these. Okay, so for part A, I'll just tell you, this is a parabola. The graph looks like this. Anywhere that I draw a vertical line on this graph, it's going to hit that graph at most once. Okay, that's the basic idea. It's not going to hit that graph more than once. So it's going to hit it once, but not more than once. Okay. Now, so this is yes, it is a function. It passes the vertical line test. Okay. Now this one, I'll just tell you, it's going to look like this. Now you might be able to see that it looks like this because it's going to be like the same thing but switching the roles of x and y. But the point is here, vertical line doesn't touch the graph. At x equals 0, we haven't failed the vertical line test yet because it's only touching one point. But then as soon as we get x positive, any vertical line will touch this graph more than once. So no, fails vertical line test. Now, x squared plus y squared equals 25. Again, you might recognize this, and if not, that's okay. This is the equation that determines a circle of radius 5 centered at the origin. So again, over here, we're not failing the vertical line test. If we get right to this point, x equals -5, we're not failing the vertical line test. We just have a 1 point. But as soon as we get between plus and minus 5 for our x value, we're going to touch the graph in more than 1 point. So no, this fails the vertical line test. Okay. Now for this graph, I'm just going to tell you it looks something like this. I don't want to get too much into how to graph this right now because we're just trying to do vertical line test examples. But if you're curious on how to graph this, I would recommend going to Wolfram Alpha. So that's Wolfram Alpha. If you Google this, or I think it's wolframalpha.com or something like that, you can just type in graph this equation, and it's pretty easy to figure out how to get exponents by using the caret symbol and stuff. Wolfram Alpha is a great resource for checking your work. It's not a substitute for thinking, but it's a great resource for checking your work. So again, here, passing the vertical line test, and then once we get past 0, we're touching this line in only 1 point. So so this yes, this passes the vertical line test. And finally, I want to do some massaging to this formula. So we have y equals, let me factor out an x. I've got x times x squared minus 1. And x squared minus 1 can be factored. This is a difference of squares. So we can factor x squared minus 1 further. So this is x times x minus 1, x plus 1. So remember, a difference of squares can be factored like that. So without knowing exactly what this graph looks like, I can see that it's got a 0 at 0, because when x equals 0, it's 0. When x equals 1, this becomes 0, so it's got a 0 at 1. And when x equals -1, this becomes 0, so it's got a 0 at -1. And I'll just tell you again, we'll spend more time with this later, but for now, just this is what it looks like. So again, if I attack this with vertical lines, no vertical line will hit this more than once. So again, yes, it is a function as it passes the vertical line test. Okay, So the last thing, oh, sorry, so I guess I should say, so in general, this is how we use the vertical line test. We look at a graph and see if vertical lines touch the graph more than once. Okay, so the last thing I want to do is really quickly just an example where we find the domain of f. So remember, we want to stick to real numbers in this class, so we're going to avoid numbers with imaginary parts, so with non-zero imaginary parts. So find the domain of f, where f of x is equal to the square root of 3 plus x divided by x minus 2. So I want you to take a minute and look at this and think about what are the classic sort of mistakes that could be made, or what are the ways to break the laws of mathematics when we're analyzing this. Okay, so a couple of rules, and we'll eventually learn more rules, but a couple of rules that you should know are, one, we want to make sure we don't take the square root of a negative number. So we want to avoid the square root of negatives. Another thing, we don't want to divide by 0. Right? We don't like dividing by 0. So what would lead us down those paths? So solution, if x is less than negative 3, what happens? Well, let me get to x is less than. I'm kind of putting the cart before the horse here. I know that I need the square root of anything to be positive, so we need 3, or non-negative. We need 3 plus x to be greater than or equal to 0, right? Because the radical can't take a negative input, or that would give us a complex output. So this means that x is greater than or equal to negative 3. So this is part of our domain. Moreover, we know we can't divide by 0, so putting the cart before the horse again, x minus 2 cannot equal 0, which means x cannot equal negative 2. So let's look at our number line. We're here at 0. X cannot equal positive 2. Sorry about that. So we're here at negative 3, and we're here at positive 2. There's some action at both of these points. So at negative 3, okay, x can equal negative 3. That's all right. And we're going to go forward until we hit 2, and then we'll keep going past it. Another way you might want to indicate this is you might say, so negative 3, 0, and you're not strictly required to put 0. It's just, I think it's a good habit to have some idea where the 0 is. You could do it like this. So because as soon as x is greater than 2, we're all gravy. We could also say the domain is negative 3 up to 2, parentheses, union 2 to infinity. So all of these, I guess I should say any of these are perfect answer to this question. Okay, thanks.